In this lab, genetic engineering, what we want to do is we want to teach you how we can make copies of genes that humans may want. For example, some individuals who have diabetes are unable to make insulin. If you're unable to make insulin, you can't break down sugar. So typically what diabetics will do is take insulin shots if they have type 1 diabetes. But where do we get the insulin from? It turns out we can take the gene that makes insulin and we can use a gene from a cow or a pig because it's identical to our own. Scientists can identify it and they can isolate it. Here's a gene sequence and it codes for insulin. And what scientists can do is they can take a bacteria and they can use something inside the bacteria called the plasmid. Plasmid is a circular ring of DNA. Plasmids have the ability to take in foreign DNA. So what scientists can do is they can take restriction enzymes and they can take the DNA inside the plasmid and they can cut it open. When they cut it open, they can insert a new gene. In this case, they can insert the gene to make insulin. And then, when the bacteria makes a copy of itself, the bacteria will now be making a copy of itself, its DNA, and the gene that we wanted, which was insulin. So in this activity, you're going to be asked to make a plasmid and show how a plasmid can be cut with an enzyme and how we can insert a new gene of interest into that plasmid. So the first step, you're going to take one of your colored pieces of paper, and let's say you had a red piece of paper, and this strand of DNA is going to represent the DNA found in the plasmid, and the plasmid is the DNA of the bacteria. So write the exact same sequence that's right here onto your first strip of paper. So write down GATTACAGAATT CTAGACATGTTCCAGATGC. And then on the other side, write the complementary letters C, T, A, T, G, T, C, T, T, A, G, A, T, C, T, G, T, A, G, A, G, G, T, C, T, A, C, G. The next step is to take the other strand that's on step 4, I believe, and write this exact strand on your other piece of paper. This represents the gene from the cow or the gene from insulin. So write the above strand GAATTCCGATTCGAATTCG on that other strip of paper. And then on the opposite side, you're going to write the complementary letters. So C, T, T, A, G, A, T, G, T, G, G, C, T, A, C, 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 T, T, A, G, C, A, T, C, G, A, T. Then, after you've done that, you're going to make the mark. You're going to act like the restriction enzyme. And what the restriction enzyme does is cut DNA at a very specific spot. In this case, the restriction enzyme is going to cut the DNA anytime it sees an AATT. So in this case, just going to make the line a little thinner. We're going to have AATT. Wherever I have AATT, I'm going to make a line. So on the red strip, there's one sequence of AATA, so I make a zigzag. And then down below, I have an AATT here. And I also have an AATT here. Once you've made those zigzag lines, what you did is you're marking where the restriction enzyme cuts the DNA. So it turns out the insulin that we want is right here, in between these two zigzags. So the red piece has gotten divided up into two pieces, 1, 2, and the blue piece has gotten divided up into 3 pieces. You're not going to need piece 1, and you're not going to need piece 3. What you're going to do is you're going to insert piece 2 from the blue in between 1 and 2 of the red. And you're going to tape those all together like a puzzle piece. Then you're going to turn that one long strip into a ring, and that's what you're going to bring to class. So when you cut your pieces together, you'll get something that looks like you'll have your red, and then inside the red you're going to have your blue, and then you're going to have your red. So you'll have your 3 pieces, 1 and 2 from the red and 2 from the blue. You're going to tape those together, and then you're going to make a ring. So your ring is going to have the red, and then it's going to have the blue, and then it's going to have the red. And then that ring or plasmid is what you're going to bring into the classroom. So what bacteria can then do, now every time the bacteria makes a copy of itself, it's going to copy the plasmid, and it's going to copy the gene that we want. So the first time it replicates, you get 2 copies of the new gene. The second time it copies, you're going to get 4 copies of the new gene. And this is one reason why scientists like to use plasmids, because bacteria replicate really quickly. In an hour, you can get 50 to 100 copies of DNA because they just keep replicating over and over again. So you can see the number of bacteria keeps replicating, and every time the bacteria replicates, you're going to end up with the plasmid, and inside that plasmid, you're going to end up with that gene for insulin. Scientists can then take the gene out and use the gene to make medicine. So I hope that helps you to create your plasmid.